Okay, so here's the solution to question 1, exercise 5C, where we're given two coordinates that make up a line segment, and we are given a third point that splits them in a ratio, and we have to find the coordinates of that third point. So here we've got A and C, so I've drawn my line segment. I've then transferred the coordinates of A, 2, 3, -1, and I've just written them kind of in column vector form, just so that they're a bit easier to work with in a second, and I've got my point C here. We're told B splits this line in the ratio 1 to 2. I haven't marked in B yet, I'll deal with that in a second, but the first step to these sort of questions is simply to find the difference between the x, y and z coordinates of each of these 2 points. So if we start by looking at A, which has an x coordinate of 2, and C has an x coordinate of 8. So I'm just going to find the difference between 2 and 8. So that difference from 2 to 8 is obviously a difference of 6. So I'll just mark that in there. I then look at the y coordinates. From 3 to -6 is a difference of -9. So you need to be quite careful with that. And then the difference between -1 and 8 is a difference of 9. So that's what I've got here are the jumps between an x coordinate of 2 and an x coordinate of 8. It's a jump of 6. This is a jump of -9, and this with the z coordinate here is a jump of 9. So what we're now going to do is we take these jumps and we split them into the ratio 1 to 2. So a ratio of 1 to 2 tells me that I've basically got, I do my jump in 3 parts. I do a jump of 1, and then I do a jump of 2 parts. Okay, now the important thing there is that that's in parts. It's not a jump of 1 in terms of the coordinate value. So I am going to do this jump of 6 in 3 parts. First of all, a jump of 1 part, then a jump of 2 parts. So I'm going to look at each of these jumps. So if I did a jump of 6, I wanted to do it 1 part, then 2 parts, well, 6 is going to split into the ratio 1 to 2 as 2 and then 4. That basically means this total jump of 6, I would do it as a jump of 2, then a jump of 4. So this jump of -9, that's going to split into the ratio 1 to 2 as -3, then -6. And then finally, the jump of 9 in the ratio 1 to 2 is to do a jump of 3 and then a jump of 6. Okay, so that's how I deal with this ratio applying to these differences between my coordinates. So now all I need to do is I tend to go back to the first point I'm given, and then I'm going to apply these jumps here to each of them. What I could do is I could go to my second point and apply the second part of the jump and kind of jump backwards. But I'm just going to imagine this is point B here. So I'm going to start at A, an x coordinate of 2, and I now know I need to do a jump of 2. Okay, so I'm doing a jump of 2 here, and that's going to take me to an x coordinate of 4 now. So now I look at my y coordinates. I was at 3, but I'm going to do the first part of my jump by going down 3, -3. So I'm now going to be at the y coordinate of 0. And then finally my z coordinate, I'm at -1. The first part of this jump of 9 that I needed to do, I'm going to do it as 3. So I'm going to go from -1, jump up 3, and I'm going to end up at 2. And now that becomes the coordinates of point B. So B will be the point 4, 0, 2. Okay, and that's my solution there. So the process there is, first of all, find the differences between your first 2 points, split those differences into the correct ratios, and then apply that change to your first coordinate to find B.